Hello, today I will show you technical task. Um, we discuss ways of solve this task and I show my variant of completed technical task. It's pretty simple. You just need create ERC20 standard token with name test symbol TST. Maximum supply is 1 million tokens and token has 8 decimals. Creator upon deploy receive 5% of max supply tokens and this token must contain lottery logic. When deployment execute, we must create timer variable with timestamp and store the currently time. Further, when someone transfers this token, we must calculate extra rewards in next logic for 1 second. Since previous transfer, we must add 1 token. So if between transfers past 1 hour, we must calculate 3600 TST tokens, and then we must these rewards give to the winner. After each transfer, timer resets. Process continues until max supply of tokens reached. Burn logic we don't use in this token. One of requirements is that function transfer or transfer from must cost under 150,000 gas. So we can't create expensive logic, yeah. And next in task we see that ideally smart contract alone should execute all functions related to choose the winner. So technical task propose to us include all logic of lottery inside smart contract. Okay. Next, logic for choosing the winner. From smart contract information we have holders, balances there, and next requirement that holders can be 2000 or more. Yeah, so we must create logic which will work with 2000 addresses minimum. Okay. So logic for choosing the winner. All holders placed in lottery list. It's just mapping in Solidity with key it will be address of holder, and value it will be mm, true or false, something like this. Yeah. And each not like this. Key will be index from 1 to total supply, and value will be address of holder, in that way. And all holders are placed in lottery list and moving from center and moving to the right. So if we have 4 holders, for example, and first has 5 tokens, second 5, third has 3, and fourth holder has 1 token. So we put them all in total supply of tokens, now 14. So we put these holders from the center to right, and we fill this list red, green, blue, yellow. Yeah. Next we see that this fourth holder doesn't have enough tokens, and we move in the other side to the left. We fill list in this way. Stop it and move to the right side again until we spend all virtual balances of holders. It doesn't touch real doesn't touch real balances. Just copy information from these balances and use it for allocation to create lottery tickets. For example, if holder with 10 tokens can receive only 10 lottery tickets. And then we must create random number, generate some way, and choose some. This random number will be key and value will be address of holder, and this address will be winner, and all extra rewards which will we calculate in previous actions, we must mint to the winner. Okay, so I propose to you push pause button and think about this task, how it can be created and executed. Okay, next. Next, I will show how I do this. First of all, I find I noticed this word. It's not ideally, not requirement absolutely. So it's this moment we can't do this in Solidity code. It's impossible because cost of this transfer, we need to create cycle through all holder addresses. Imagine if we have 2000 holders, how it be? It's cycle about 2000 iterations. 150,000 guess it will be, I don't know, for 5 iterations, 6. I need 2000. It is impossible. So I just realize that logic for choose winner we must implement in backend. We can't do this in Solidity. It's just impossible. Alright. How it can be done? Let's move to Solidity part. And this is pretty simple ERC20 token from OpenZeppelin 5 version with permit. It's code little slightly more difficult compared with fourth version, but we choose it, just modify just little. So first of all we have abstract contract nonces. It's standard, just for interaction with permit and nonsense. It's internal libraries utilized for calculate storage slot, and we have EIP 712 ECDSA library for permit, and context, ERC20 interface metadata, ERC20 abstract, and permit. ERC20. Just I copy ERC20 some functions from first version, because I don't need update function from 5 version. I don't like it much, because I need override functions, and I need to override mint and add some specific logic only for mint. But 5 version is don't allow me do this, because update update is used in mint, in burn, and in transfer too. Okay, so let's move to main contract. What we have here? Let's it's just max supply. Yeah, it's our timer. Operator I and client type hash I will show you later. constructor. We just create and mint tokens to the owner and start timer. That's a mouse. And here we override transfer function. Just calculate rewards. Here this function pretty simple. And these rewards will be and we emit event with this variable. We modify ERC20 interface and this event and add some additional field unit 256 rewards, and this field include our extra rewards which we must emit to the winner, and we emit transfer with this information after each transfer. Next, we can listen this transfer. We can work with this information, and I show you later how we do this. Next, it's just override mint for max supply. It require for max supply. And the next function is claim rewards. Idea of this logic, it will be next that we can listen transfer. We can listen information about extra rewards. And next backend will do all logic of choose winner, and next we define operator. It's just well-known address from Hardhat or Foundry, and we set this operator in our code and assume that this operator is from deployer. It can be deployer address or some other address which controls by deployer. And in backend, deployer must have a private key for this address, and after choose winner, backend must create signature with information about extra rewards from this event, and show to the winner this signature to the winner, or just to the main website page, and winner can use this signature and go to our smart contract and invoke this function claim rewards. He sent his address, value, how much he want to mint, how much extra rewards he win, deadline, and VRS, it's from signature information. And logic of this function, we just check if operator sign this signature, sign this information, if this address operator is correct and equals to the signer and mint to the winner value. This way is my decision, my way to complete this task. It was just Solidity part, Solidity code, and I propose move further and go to the backend. So how it works in backend? We have Node. We have pretty simple project. With package.json we use 5 version of Ethers and Express server. We have crypto library from Node.js for get random number. We use server. We import ABI from application binary interface of our smart contract. We use FS, and we don't use database. It's simple variant. We just store our information locally. We use FS and store all information in our local files, like total supply for lottery, like empty object balances. It will be filled after transfer or deploy smart contract, and after holders for lottery it's just array, empty array, and nonce is 0 for our logic. And we import this information from these files, and next we can work with this information and modify. Notice that I choose let for variables because I modify this nonce and modify this variable too. We use provider, just public provider, because we don't need write, we just need read information, and I suppose this public JSON RPC provider must work now. Public node. Yeah, it's online. Okay. So we predict contract address here. We can use prediction of address, and we will do it now. I choose my address, paste here, and I need nonce 504, next nonce, and I have address of will next smart contract which I deploy from my address. Okay, operator, domain separator. We don't use constantly, we just fetch this from smart contract in code. Time for valid signature, we define 24 hours, and trigger, not trigger, and just flag for lottery. You can start it, you can enable it or disable. Now it's on, enable lottery, it's true. Next we create instance of contract through ethers and create lottery tickets map, which we will fill for this order. Yeah, it's simple. One token in with in backend and with 8 decimal. Okay, it just our three main function which we will invoke from here. So when we listen transfer, when we see that transfer happened, we fetch this information from blockchain and receive these fields from to value and rewards. Next, we work with them. We execute fill info base function with three variables. Fill info in base. This function is create our information, fill our files, balances and holders for lottery in specific logic. So if it is mint, we invoke handle mint. If burn, handle transfer, and when we just transfer tokens. Okay, what logic in mint, handle mint? We just read information from our base, from information from these files, then add to the event converted value and use it for fill balances. In this logic we fill balances. Next we fill total supply for lottery, because we must notice that user and one of requirements users with balance more than one token can participate in lottery. So we need to round it, and take only rounded total supply. And we push if this holder enough tokens to the array of holders for lottery. After this, after fill info in base, after handle, after mint, we have this logic from FS. We write all information into our the database locally. Yeah, you can use MongoDB or some other kind databases, but it's just technical task, and we just use local files. Same, just logic, it's logic for burn, logic for transfer, and it's we fill balances, we work with holders for lottery mapping, not mapping, it array holders for lottery, and this check if holder after transfer not have enough tokens. If for example he has 49 and he transfer these 49 tokens to some other dude, so address from it not will participate in lottery, and we just delete this address from array holders for lottery, and fill balances, and push new holders. And work with total supply around it. It logic for fill info in base. After filling information, we must do what? After mint, we must don't do anything. After mint, we don't do anything. We just fill info and not choose winner, because we just mint rewards or mint when deploy smart contract mint tokens, and we don't start logic for lottery. So we have requirement only for burn and for transfer. However, burn logic in our Solidity smart contract is not implemented, but I just decide do this for good, for all. Okay, if we if someone transfer tokens, let's see how it happens. We in case of transfer tokens, we also fill info in base and move to this part of code. And we execute invoke create lottery tickets function. This function is our main logic for create creation and creation of this particular lottery tickets list. We just copy information from database, and it's very important do exactly deeply copy information, because if you use just spread operator here, you don't receive independent copy of balances information. You don't receive independent copy of database information. Next, we just divide our total supply tokens. So if we have 14 total supply tokens, we divide it will be 7, and we create right start point, which will be 8 in this case, 8, and left start point it will be 7, and move from right start point to the right and from left start point to the left, and fill this list. I think there can be more efficient way, filling this info, but I just do in this way, because we have in our case difficulty in big O. It will be ON, and if we do some optimization, I think we can do this log O log n, logarithmic difficulty, but it's I need spend some time, and just I don't do yet this. Okay, so we just move to the right and to the left. Okay. This we don't do it in when we move to boundary of total supply. It in finish in end logic, and we just start from here. So we have count 0, and we don't have holder stamp length more than total supply for lottery round and minus right start point plus 1. We don't go to this if, we go to the else. From beginning and just start fill this mapping. Set raster for this index. We store this value with address of holders, and then we just store information about his balance, temporary balance, work with this balance, and next logic if balance of this particular holder will be one token will be more than his balance, we just add some variable for holder, it will be indexing our balances. I will show you how I store this index, and I increment some counter which I use further, and we work with total quantity. We just append right start point for holders temp length. If we have 5 holders, we just move right start point for right in the right to 5, and if we have for second iteration 3 holder, we just add only 3. Counter for next iteration of while we go to another else, because count will be 1, and move to the left side and do exactly what it will be in what it was be in right side. Okay, this logic for creation this mapping. So we create mapping like this. Yeah. Next we create mapping, and it's very simple logic for choose winner. Just get random from library crypto and execute lottery. Just retrieve information from this mapping for with this index and this some number. Next we move to the creation of signature. We have information for extra rewards from event. Here rewards is information about extra rewards which must we give to the winner. We have finally address of winner, and we can create signature for him with this information. Create signature is just simple function. We just use specific type hash this for this function. I just a little slight modify permit type hash because we don't need owner and spender, just need address of winner, and we just need constant of claim type hash. It's same here like here as here, yeah. This is same values, and we just use in creation of our signature. So we just in code use Solidity Keycheck 256 function and create hash and sign this hash private key of count from hard hat. Just for example, it's don't use this private key somewhere. It will. I know some our other developers know this key too. Don't use it production. And we sign this signature and return it to our server. Next we split its signature for whereas and show to user. That's it. We can use its signature, go to our smart contract and claim winner, go to smart contract and receive his rewards. Okay, so I propose do some fast test. I have not good variant for mapping here, because if we have mapping in console log, we can see lottery tickets in beautiful way, but if we have not 50,000 tokens, but now we have just much more information, and you can modify this code and don't mint 50,000 for deployer for owner. You can mint for example 20 or 30 tokens, and it will be more information this mapping, it will be more beautiful view, but now it just much more information. I can show you maybe in some iteration. I show you how we can see. So let's deploy our smart contract in Goerli. This token test can deploy it. Okay, up. I forget start server, yeah. So we need just next nonce use this address, paste in server and start it. Okay, sorry, and you can just repeat these actions. Wait for deployment. Few seconds. Still pending. Weird. Yeah. Okay, it's done. It's done, and we have log of simple information. We already have field from. We have here 0 address to our deployer, value how much was minted, it 50,000, and reverts 0. And we see before balances, and now we move to this file. Remember, it was empty, just object, and now we store information about our holders, and store information here, and nonce still 0, and here we have total supply for lottery, rounded. If I transfer now half of token for someone, what do you think will be total supply for lottery rounded? It will be subtracted by 1, because we must round all this information, and we must use only rounded numbers. Okay, so this was mint, and let's for example move some assets to my another account. Let's for test move store way. It's just simple. It's below 1 token, below 1. How much holders for lottery we must have now after transfer? Only one, because we transfer below 1 token, and after execute this transaction you can see it too. We can see balances in modified balances, because we just add some assets, add some tokens to this address, but in holders for lottery mapping we don't see my other account, we don't see this address. This dude don't participate in lottery now, and in balances he doesn't have index. Okay, let's make him little rich and move for example 1000 tokens. We remember that we have 8 decimals, so we add 8 zeros here. Like this. And you notice that we create signature already. This signature, obviously winner will be my first deployer account, but we can see lottery ticket number, and we can see lottery ticket size. That's another nonce, and you can see that in holders for lottery we have already two addresses, two holders which are participate in lottery. Let's just spend some tokens from our deployer additionally, just for testing. And already all work correctly. We have all these nonce and information. Okay, I pledge to you show how you view of lottery tickets mapping, and for this we can stop server. Don't worry, we just start it later. All information we have stored in our database, locally database, and we can stop it and move, just create some modify. I just want to uncommit this console and start node server again. So let's use this address in last time and move to it again 1000. And now you must see very long information. It will be 50,000 lines of code from this mapping, yeah, and it's still created and showing to us. It's because of I now do record of video, it work very slowly. Without OBS it work more faster. Yeah, it's speed up, just speed up. Okay. And we can see how it mapping feeling, yeah? It moved to right, left, right, left, right, left. And in end part we have index 1 and last index of equal to the total supply rounded lottery ticket size. Is how it this mapping view. Okay, it's a long video, and last from this task, I want my money, I want my winner. Yeah, so who is winner now? It is my deployer. Okay. Okay, just check balance of deployer. You can see this balance, and I propose use signature for this from this folder. For this address we have nonce 3, and we have this signature, this signature. Okay. What we need to do? Okay, we need copy R. Yes. Deadline. Value we can use from our event, last event value, where 27, and winner. I think yeah, it will not execute because we have nonce here 3 and here is 0. Nonce of operator still 0. We can't receive rewards until other holders, other winners receive it. It not good, but I think I can spend some time and solve this problem in future. Okay, I made mistake in generation signature because I use nonce for operator, but in our case we can do this because operator nonce if it will be created for first winner and then for second and for third, and if first winner can't if he didn't claim his rewards, second and third can't do this too, because we have increment this nonce in smart contract, and it will be done as well as we increment this nonce backend. So I modify claim rewards function. I remove from arguments address winner. I replace it for message sender and use it message sender further, and I use nonce from message sender from user, and in this case we must delete deadline. So because if winner has multiple rewards and not claim his first reward before deadline, automatically second or third and other reward he cannot claim too, because he can't increment nonce correctly. It is solidity modification in JavaScript part in server. I just add nonce variable and read from our database information which will contain in file nonces. Now it's just empty object, and use it in create signature function here, and increment and assign to nonces winner again, and write to database. Now I start server already and just do deploy. Injected. Nice, deploy. Wait for deployment. Maybe I need use hard hat for Foundry for videos. They doesn't have such pause. I use incorrect nonce and start server with incorrect address, but let me fix this in few moments. Yeah, now we listen our address of test token. Okay, and we must execute for test some transfer. Okay, script create signature. We see nonce 0 in file nonces. We have this guy, and this is winner. Obviously it's one address one holder, and we can see nonce 1. It is nonce currently. For this signature was be used nonce 0. Okay, next just wanna send some tokens to my another account, and I wanna show how claim reverts with this script, modified script. Yeah, we can see nonce is incremented, create signature with nonce 1, and we have winner still this, but let change this. I think if we send 48,000 tokens from 50,000 total supply, we have another winner. Let's see, maybe first guy be lucky. No, we have a winner, new winner with this address, and he can claim reverts with this signature, but it will be work correctly. But if this guy wanna claim his reverts, he must start from reverts with 0 nonce. He must execute first of all this signature, after it he can execute signature and claim rewards with nonce number 1. Only after this he can claim any other rewards. So let's claim, for example, from this guy, I think. Yeah, we can see he has 48,100 tokens. Okay, let's see how much rewards he can claim from event, and this is rewards, and here we have S R and 27 from this guy, and we execute claim and correctly estimate gas for this, and transaction completed successfully. Now we call balance, and we can see that balance is penned. That's it. Thank you for attention.